Welcome to NASA Data Made Easy, Tools for the Ecological Data Revolution. Hi, I'm Sarah Lubkin. I work at NASA headquarters with the Earth Science Data Systems program. Other speakers today are Cynthia Hall from the Earth Science Data Systems program's communication team, Jessica Welch from the Oak Ridge National Lab or ORNL Distributed Active Archive Center, or DAC, Cole Kriebel from the Land Processes DAC, and Leah Schweitzer from the Earth Science Data Systems GIS team, or EGIST. After I give a brief introduction, Cindy will talk about how you can get started using NASA Earth data with Earth Data Resources. Jess will talk about data and tools at ORNL DAC, and Cole will follow with information about data and tools at LPDAC. Finally, Leah will talk about resources for GIS users. NASA's Earth Science Division uses the vantage of space to study the Earth processes that power climate, weather, and natural hazards, and the impact of those processes on life on Earth. NASA gathers information about the Earth from a fleet of Earth-observing satellites. This slide shows the operating satellites in blue and green, and those that are in development in purple or in planning stages in orange. These satellites allow NASA to gather data about the whole Earth system. On the left side of the slide, there's a list of some of the observations and measurements that NASA collects through its orbital, airborne, and field programs. Many of these, if not all of them, are relevant for ecology, and you might find some that are relevant for your research. The Earth Science Data Systems program actively manages NASA's Earth science data as a national asset, whether it comes from satellites, instruments on the ISS, from air campaigns, or from field data. We believe the data is valuable not just while the mission operates, but well into the future. Our job is to develop data systems capabilities that support rigorous science as well as interdisciplinary research, applications use, and even commercial use. And we make sure that the data is quality controlled, has the necessary metadata, and works well with other data so it can be used by anyone who needs it. And of course, NASA data is free and open, and this philosophy includes tools and services on our Earth Data website and at the DACs. And finally, we work to engage the Earth science community in our efforts so we can understand user needs when developing our data systems. Like I said, NASA data is open and you can use it for any purpose with no restrictions. NASA data is also fair, and this means we work to ensure that our data is findable, accessible, interoperable, and reusable. Findable means the data are described with rich metadata and there is a DOI and the data is always associated with that DOI. Accessible means anyone can access the data. Interoperable means the data are available in standard formats so they work well with other data. And reusable means that all data are well documented so science can be shared and replicated. NASA Earth data is made available to the public through the Earth Observing System Data and Information System, or EOSDIS. Once the data from satellites is captured and cleaned, it goes to EOSDIS where it is processed and archived and distributed to the public for science, applications, education, policy making, and commercial use, so pretty much anyone, anywhere can use the data for any suitable reason. EOSDIS, the Earth Observing System Data and Information System, is made up of the SIPs and the DACs. The SIPs, or Science Investigator-Led Processing Systems, do forward processing of standard products and reprocessing to incorporate algorithm improvements. The DACs, or Distributed Active Archive Centers, process, archive, document, and distribute data. They also assist users in selecting and obtaining data, provide access to data handling and visualization tools, notify users of data-related news, provide technical support, and they're always happy to answer your questions. The DACs are organized by scientific discipline. Jess is here from ORNL DAC, and this is the DAC for Terrestrial Biochemistry and Ecological Research. And Cole is here from LPDAC. LPDAC is the DAC for NASA's land remote sensing data. The DACs are a bridge between the data and the science community, and each DAC has unique tools created for their user communities, and Jess and Cole will talk about some of those tools today. EOSDIS is the single largest repository of Earth science data. Here are a few facts about EOSDIS. ecologists has over 33.6 and growing petabytes of data distributed among the DACs. These include over 12,000 unique data products that have been used by more than 570,000 unique users. This data also includes some near real-time data that is made available to the public within 3 hours of collection. And this data can all be accessed through the Earth Data website and through the DACs. Earth Data is our centralized website that allows access to the data at any of the DACs. Earth Data has two important resources to help you find data. Earth Data Search is data-centric. Users search for data across all the DACs by choosing what they want to measure or what instrument they're interested in, and they use the site then to search for the data they need. Worldview is a visual search that allows the user to zoom in on an area and choose from all the data sets that are available for that area. But this can still be confusing to the new user. Earth Data Search, for instance, lets you choose any term. Here I searched for land surface temperature. But what do you do when you get more than 3,000 search results? How do you sort through that? Next up, Cindy will talk about some of the resources to help you get started with Earth Data.